Good morning, guys. Welcome to our class. Today in this session we'll be starting Laplace transform. Laplace transform is one of the most important topic of mathematical physics, and in every paper you almost get one question from Laplace transform, either from Laplace transform or Fourier transform or from both. So it may not give you direct question in the form of Laplace transform that find the Laplace transform of this. Sometimes they can give you an integral to find, where you may use the concept of Laplace transform. So today we will be talking about that, where you may use the concept of the solution of the last day's homework problem I have already shared on the WhatsApp group. You can check the solution there. Now today we will be starting this Laplace transform. This is very easy topic. I guess it is easier than that Fourier transform. If you have understood Fourier transform very well, then you can easily understand Laplace transform. There is no issue. So let us talk about the basic definition. What the basic thing about Laplace transform? Laplace is a name of a scientist. So the Laplace transform is named after that inventor of this transformation, Pierre Simon Laplace. So Laplace transform is also an integral transform. Fourier transform was an integral transform. Laplace transform is also an integral transform that converts a function of real variable t. Let's say if you have a function f of t in the variable t, if you take the Laplace transform, it will get converted in a complex variable s. So we denote it by f bar s. Okay, this is the Laplace transform. So as you can see, it is coming in terms of the complex variable s. The transform has many applications in science and engineering because it is a tool for solving differential equations. So this is the main application of Laplace transform. This using Laplace transform, solving differential equations becomes very easy. We will tell you how to do that, but just know this thing that Laplace transform has got main application in solving differential equations. In particular, it transforms differential equation into algebraic equation and convolution into multiplication, which are much easier to solve. Okay. Good morning, Harani. So this is the basic thing about Laplace transform. We will now go for the mathematical definition because that is of utter importance for us. Good morning, Ajay. Is it done? Now, how do you define this Laplace transform mathematically? So, give the heading definition of Laplace transform. So, if you have a function, let us say f of t, so Laplace transform of function f of x or f of t, whatever you say, f of x is defined in the interval. Now, one basic difference between Laplace transform and Fourier transform is, in case of Laplace transform, we consider the interval between 0 to infinity instead of minus infinity plus infinity, which you take in Fourier transform. Laplace transform of function f(x) is defined in the interval 0 to infinity, and we write it in this way, that Laplace transform of f of x is equals to f bar s. This is equals to 0 to infinity e to the power minus sx fx dx. So this is the original formula or main formula. Just remember this. All the other formula or short formula I will be giving you, but those formula can be derived from this main original formula. So this original formula you need to remember, e to the power minus sx fx dx. Now what are the conditions for the existence of Laplace transform? So you can easily understand this. Conditions for the existence of Laplace transform. Now if you carefully look at this integrand, this should be we are expecting it to be a finite quantity, right? So this integrand e to the power minus sx fx, it should be a finite number as you go to the infinite values of x. You can see the limit of x is running between 0 to infinity. Now when you take the higher values of x, when you are approaching towards infinity, this integrand should be a finite quantity, should be converging, right? We have used this condition in some of the problems which came in 2024 June exam also. So that is one of the condition. Another condition is that this function f of x should be piecewise continuous in every interval. Okay, the function may be given in this form. It should be piecewise continuous in every interval. So that is the first condition. F of x should be piecewise continuous in every finite interval. Number 2, look, e to the power minus sx fx, this is the integrand. It should be a finite quantity in the limit of x tends to infinity. That should give you a finite quantity and the limit x tends to infinity. So this is just two conditions you need to know, but when you will actually solve the problems from Laplace transform, this condition need not to be verified. Okay, you will just apply this formula. This is just for your information. Let me know once it is done, then we will go for a problem. The first problem you need to try by yourself. I am just giving you the first problem. Let's see whether you can do it or not. I hope you can do it. Came in December 2016. The Laplace transform of f of t, where f of t is t by t between 0 to t and 1 in the limit t greater than capital T. So you can also draw, there is no necessity to draw the function, but let's draw for the sake of completeness. You can directly apply the formula. 0 to capital T, between 0 to capital T, it is t by capital T. So it is a straight line. like this, and beyond t equals to t it is 1. Do it quickly, this one. Are you able to proceed? You start with the basic definition of Laplace transform. 0 to infinity, e to the power minus sx fx dx, so e to the power minus st f of t dt. This will be the formula. देखो, this is equals to, so let's decompose the integration limit. Once 1 is 0 to t, between 0 to t the value of the function is small t by capital T, so just put that value, and between t greater than 1 means t to infinity, the value is 1, no issue. T to the power minus st dt, let's evaluate that. So capital T is a constant, we can take it outside, and t to the power st means we can use this formula of uv dt, okay, uv dx formula. What you will get, t is u, e to the power minus st is v, so to the power minus st by minus s, limit goes from 0 to capital T. Again another term, derivative of t is 1, e to the power minus st by minus s dt. This term will come from the first part. The second term will give you e to the power minus st by minus s, limit goes from t to infinity. So this is equals to 1 by t. If you put the value of small t, so capital T by s with a minus sign, e to the power minus s capital T, okay, minus, and this is 0. Now if you put the value of t here, what you gonna get? E to the power minus st minus 1 by s square. So you have to evaluate this e to the power minus st. So e to the power minus st by minus s, minus minus plus s square, and that is how we have got this one. We have jumped one step here, and if you put t goes to infinity, the first term is 0 plus e to the power minus st by s. Okay, now this will become e to the power minus st by s, and this one plus 1 minus e to the power minus st by s square t. It clear, guys? There is a minus actually, plus e to the power minus st by s. So these two terms get cancelled. So you have 1 minus e to the power minus st by s square t. Option B. Is it done? Let me just give you some of the important list of Laplace transform. What will be the Laplace transform of 1? So if you take f of t as 1, what will be the Laplace transform? It is 1 upon s. This will be used very much. Laplace transform of x to the power n or t to the power n, whatever you say. This will be n factorial by s to the power n plus 1. N may be 0, 1, 2, 3 and so on. Laplace transform of e to the power ax. Look, what is the meaning of this? You already know, 0 to infinity e to the power minus sx e to the power ax dx. Okay, so this is the underlying meaning of this thing, but you have to directly remember this formula. Each time you cannot evaluate all the integration, so you need to remember this formula to apply it in some problem. Laplace transform of e to the power ax will come out as 1 by s minus a. If you calculate using the original definition, you will get this one. So if it has e to the power minus ax, then it will become 1 by s plus a. Laplace transform of sin ax. Sin ax will be a by s square plus a square. S is greater than 0. Okay. This condition you need to remember. You can just remember the formula. Laplace transform of sine hyperbolic x, this will become a by s square minus a square. Good, Harry. You got the same answer, no? Laplace transform of cos x, this is, look, in case of sine you get a on the numerator, in case of cos you will get s on the numerator, other things will remain same, s square plus a square. Now when you consider the formula for cos hyperbolic, what do you expect? Look, for sine hyperbolic it is a by s square minus a square, for cos hyperbolic x will be s by s square minus a square. For hyperbolic this minus sign will appear. Clear? So these are the basic formulae, and gradually we will be giving you all the formulae. Then I am trying to give you a set of formula, then we will be doing related problems so that you understand these things better. Once this is done, we can move towards a problem. Try to do this problem. The Laplace transform of 6t cube plus 3 sin 4t h. You know the formula. You know the formula of t to the power n. You know the formula of sin 80. So you can easily do it. Tell me quickly. Could you find out the question? Could you find out the answer for this question? Option A, yes. Let's see. So Laplace transform of 6t cube plus 3 sin 4t. So for the linearity property is also applied here. So we can say Laplace transform of 6t cube plus 3 times Laplace transform of sin 4t. Okay, 6 is a constant. Laplace transform t cube is n factorial divided by s to the power n plus 1. So n is 3 here, so we can write 3 factorial divided by s to the power 3 plus 1 plus 3 times sin 4t. So for sin, you know, a comes a by s square plus a square. So this is 6 into 3 factorial, 3 into 2 6, 36 by s to the power 4 plus 12 by s square plus 16. Series matching with option A. Clear? Yes. So this property which you have used, this is a linear property. From this line to this line we could write because of the linear property. So let us now talk about some of the important properties of Laplace transform. Properties of Laplace transform. You can give the heading properties of Laplace transform. First property is the linear property. Linear property. The linear property says that if you calculate the Laplace transform of a linear combination of functions, let us say a1 f1x plus a2 f2x plus a3 f3x and so on, the Laplace transform will be the sum of the individual Laplace transforms. This is the linear property. Let us go for the second property, shifting property. What is there in the shifting property? Let us say if Laplace transform of f of x is f bar s, then if you multiply e to the power ax with the original function, then it will shift this Laplace transform. What it will become? Look, if you multiply with e to the power ax, f bar s will be f bar s minus a. If it had e to the power minus x, it will become f bar s plus a. Okay. Let me give you some examples. Laplace transform of cos ax, what do you know? It is s by s square plus a square, है ना? Then Laplace transform of, if you multiply e to the power ax, so a is already there, so let us go for bx, cos ax. What do you expect? As I have said you, if you introduce this e to the power x, s will become s minus a. So s minus b. Wherever you see s, you will replace it with s minus b. Understood? This is the shifting property. Let us go for scaling property. Scaling property. What is this scaling property? Here we multiply with a scalar. scaling property. So if let us say Laplace transform of a function f of x is f bar s, then if you multiply a scalar constant with x, so Laplace transform of let us say ax, so you have multiplied a scalar with x, this will be just similar formula which we have done in Fourier transform also, 1 by a f bar s by a. So obviously if you divide by a, 1 by ax, then it will be a times f bar s. Let me give you an example for this scaling property. For an example, Laplace transform of any function, let us say cos square x, this is equals to s square plus 2 divided by s into s square plus 4. So you can derive it easily. So if this is so, then Laplace transform of, instead of f of x, if you calculate the Laplace transform of f of ax, so cos square ax, what value will you get? 1 by a f bar s by a. So 1 by a is multiplied, and whenever you see s, you will replace it with s by a. So this will be s by a whole square plus 2 divided by s by a times s by a whole square plus 4. So this is equals to s square plus 2a square divided by s times s square plus 4 square. This is the third property. Fourth one is related to derivatives and all. Let us say if Laplace transform of f of x is equals to f bar s, then if you calculate the Laplace transform of a function which is multiplied by x to the power n, x to the power n f of x, maybe you can consider t square sin t, that may be one of the functions. So we as we are doing with x, it can also be given with t, okay, t to the power n f of t. So same formula will go. This is equals to minus 1 to the power n, nth derivative of the Laplace transformed function. Let us take an example for this also. For an example, you know the Laplace transform of, let us say, sin 3x. What is the Laplace transform of sin 3x? 3 by s square plus 9, right? Then what will be the Laplace transform of, let us say, x sin 3x? So n equals to 1 here. So what we are going to do? Minus 1 to the power 1 d ds of a bar s, it is this 3 by s square plus 9. This is equals to minus 1 dds of this thing. So this is 1 by s square plus 9 whole square, a minus sign, and this 3 was there, and this derivative of s square plus 9 will give you 2s. Okay. So what does it become? This is equals to minus plus 6s by s square plus 9 whole square. Clear? This is one of the very important properties. Let us go for the fifth property. If Laplace transform of fx is f bar s, then Laplace transform of f of x by x will be s to infinity f bar s ds. Look, you have to practice a lot to remember this formula. Based on the problem, you will be utilizing the formula. Let's take an example for this also. Look, if you take the Laplace transform of sin x, so a is 1 here, so you can write 1 by s square plus a square, right? So a square is 1 square means 1. Then if you calculate Laplace transform of fx by x, so f of x is sin x by x, let us say calculate. So you have to write s to infinity f bar s ds. So f bar s is this 1 by s square plus 1 ds. So what is the integration of 1 by s square plus 1? You know it, tan inverse s, right? Limit you have to put between s to infinity. So this is tan inverse infinity minus tan inverse s. So tan inverse infinity. So for what value of tan? Tan becomes infinity, pi by 2 minus tan inverse s. So you know a formula, cot inverse s plus tan inverse s equals to pi by 2. So pi by 2 minus tan inverse x will be equals to cot inverse x. Cot inverse s. Look, I am just talking about Laplace transform, but you can easily understand what will be the form of inverse Laplace transform. It is like multiplying with L inverse on both sides. So this necessarily means L inverse of 1 by s square plus 1 equals to sin x. In all cases you can write, okay. For this one also you can write L inverse of, let us say, cot inverse s equals to sin x by x. So you can write the reverse also. So we are not learning separately, we are just learning the Laplace transform. Inverse you can do it by yourself automatically. Let me give you a very good problem, little difficult problem. As a beginner you will not be able to solve, but let us do it. That problem will give you a good insight of the Laplace transform problems. You will enjoy solving these Laplace transform problems. These problems are very interesting. You can give it a try, this problem, a little complex problem, but okay. If f of t is the inverse Laplace transform of f of s, it means f of t is the inverse Laplace transform of f of s. F of s or f by s is given by this expression, then the value of f of pi. So you have to first find out the expression of f of t, then you have to find out the value of f at t equals to pi. Now if you look at these expressions, they are not fitting into our origin, into our known formulae. So we have to do something so that it fits into this formulae. So let us try to solve this problem. First of all, what is given? F of s is given, s by s square plus 4. If it had given like this, then we could use the formula for cos, but a square is there, which is not there in the formula. Similarly, if it had only s1 by s square plus 9, we could use that sine formula, right? But here a square is there, that is making the problem complex. So f of t is Laplace inverse of f of s. So we can write it as individual L inverse of s by s square plus 4 whole square plus L inverse 1 by s square plus 9 whole square. Okay, no issue in this. And now you see, if you require square term in this form at the denominator, one formula we have done, so we can take help of that formula. As you can see, okay, this one you see, if somehow you can write 1 by s square plus something, if you take d ds, then that will give you the, look here, this s by s square plus 9 square is appearing, so it is of the same form, right? So we can take x sin 3x, so t sin 80, okay na? So it is coming in that form, Laplace transform of t sin 80. What I mean, let us say Laplace transform of t sin 80. What is the Laplace transform of t sin 80? Minus 1 to the power n d ds of Laplace transform of sin 80, that is a by s square plus a square. Okay. So, if you calculate this, it will give you minus minus plus, so 2as by s square plus a square whole square, and as you can see it is coming in that form, and from that we can write that Laplace inverse of s by s square plus a square whole square. What you can write? 1 by 2a, है ना? One by 2a times this t sin 80. Can you write it or not? Let me know if you have understood till now. This is one thing. This, with the help of this, we can find out the first term. What about the second term? Here you see 1 by s square plus 9 whole square is there. For that, we have to take up a special function, Laplace transform of sin 80 minus 80 cos 80. Look, this is a special problem, don't get frightened for this problem. Few problems require a special treatment, so it is that kind of problem, a little difficult problem which you require prior knowledge. So, you can write it L of sin 80 minus a times Laplace transform of t cos 80. Okay. The first term will give you a by s square plus a square, but the second term will give you minus 1 to the power n d ds of cos 80. The Laplace transform of cos 80 is s by s square plus a square. Okay. What is our goal? Our goal is to get a form like this, 1 by s square plus a square whole square. So, as you can see, it is a by s square plus a square minus a by minus a, and as you can see this will give you minus 1 by s square plus a square. So, we are using the derivative formula, derivative of uv. You can take let us say s, v you can take 1 by s square plus a square, or you can also use the formula of u by v. Whatever formula is suitable to you, you can use. For the time being, what we are using? We are using this. Let us say u is equals to s and v equals to 1 by s square plus a square. Okay. Look, a by s square plus a square, and here plus, so this is 2a by s square plus a square minus 2a s square divided by s square plus a square whole square, and this will give us a very good result. If you take this denominator s square plus a square whole square, you get 2a s square plus 2a cube minus 2a s square. So, these two get cancelled, and as a result you get 2a cube divided by s square plus a square whole square. Now, as you can see, it has come into the form of 1 by s square plus a square whole square. Hence, we can write that Laplace inverse of 1 by s square plus a square whole square is equals to this 2a cube. So 1 by 2a cube we have taken to the left side of this into this sin 80 minus 80 cos 80. Only this combination will give you this result. So you have to remember this. For this special problem you should have the prior knowledge of this. So in the back of your mind you have to calculate and you have to find out like what functions Laplace transform fits into. Now we can come back to our original expression for f of t, Laplace inverse of what was given, s by s square plus 4. यहाँ पे कर सकते हैं ना, therefore L inverse of s by s square plus 4 means a whole square. So a equals to 2 here, so 1 by 2 times 2 t sin 2t. So 1 by 4 t sin 2t. Okay. And here also we can find out L inverse of 1 by s square plus 9 whole square. Let's evaluate it later. First, one by s square plus 9 whole square. So a equals to how much? 3. So 1 by 2 a cube sin 80 minus 80 cos 80. (54) sin 3t minus 3t cos 3t. And as a result f of t, which is the sum of Laplace transform of 1 by s square क्या था, s by s square plus 4 whole square plus Laplace inverse of 1 by s square plus 9 whole square. This is equals to, you see what we have got for this first term. For the first term we have got 1 by 4 t sin 2t, 1 by 4 t sin 2t, and for this we got 1 by 54 sin 3t minus 3t cos 3t. Okay. Now we have to find out what is the value of f at t equals to pi. So 1 by 4 pi sin 2 pi plus 1 by 54 sin 3 pi minus 3 pi cos 3 pi. And as you can see, this first term is 0 and this first term is also 0. So 1 by 54 times minus 3 pi cos 3 pi is minus 1. So pi by 18. That is matching with option C. Let me know once it is done. Okay, let's go for another property of Laplace transform. What we have done 4, 5, 6th. Let's write the 6th property here. If you have space, you can write the 6th property here. If Laplace transform of f of x is f bar s, then Laplace transform of integral 0 to t fx dx will be f bar s by s. Okay, Laplace transform of f of x equals to f bar s, then Laplace transform of the integral of that function. What we have taken? We have taken the integral of f of x between 0 to t, that will be f bar s by s. Let's try a problem which uses this concept. Okay, look at this problem. The inverse Laplace transform of 1 by s square into s plus 1 h. Can you do this problem? Look, we know the property. If I write here, Laplace transform of 0 to t, let's say ft dt equals to f bar s by s, means Laplace inverse of f bar s by s equals to 0 to t ft dt, है ना? You can imagine 1 by s square into s plus 1 as 1 by s into s plus 1. Now if you take, let's say, f of s, f bar s is equals to 1 by s plus 1, you can easily write it like this: 1 by s into s plus 1 is like f bar s by s, है ना? So once you calculate this, again you can write this as f of s by s. Are you getting the point? Give it a try, then I will explain. If you don't try by yourself, you will not learn. If I give you the solution, you will understand eventually, but you will not learn. To learn, you must hustle, you must try by yourself. You must experience the difficulty of solving the problem for the first time. This problem can be done in two ways. One, using this formula which we are currently discussing. Another, if you just write this expression in the form of, let us say, a by something plus b by something, then you can use the Laplace transform formula to evaluate this inverse Laplace transform formula. Two approaches are there to solve this problem, but let us focus on this property based approach. You can imagine this, just forget that this s square is given, just evaluate first this problem, okay? Then we will go for this actual problem. First you evaluate this one. What is the Laplace inverse of 1 by s plus 1 by s, है ना? And whatever result you will be getting, that will be your f of t, new f of t corresponding to this. So if you consider this as f bar s, whatever thing you will get here, that will be your f of t, na? Are you able to proceed? Okay, let's do it. So we know this formula, right? So for the time being, forget this original expression. Let's first evaluate for 1 by s into s plus 1, okay? Then we'll upgrade it to this. So we can consider that f of s is 1 by s plus 1, है ना? So correspondingly, f of t will be Laplace inverse of, let's say this is f bar s, है ना? So this is equals to Laplace inverse of 1 by s plus 1. Okay, just hold on a moment. Laplace inverse of f bar s will be Laplace inverse of 1 by s plus 1. Where do you get this? 1 by s plus a. Where is the formula? E to the power minus at. So e to the power minus t. A is 1 here. No issue. So this is your f of t. First understand this one. F bar is equals to 1 by s plus 1. So f of t is Laplace inverse of 1 by s plus 1. So that is e to the power minus t. Now Laplace inverse of f bar s by s means 1 by s plus 1. This is your f bar s divided by s. है ना? So what will be this? We know the formula, 0 to t ft dt. So ft is e to the power minus t dt. Put the formula, minus e to the power minus t 0 to t. So what do you get if you put minus e to the power minus t minus plus 1. Clear? Now imagine the way we calculate for this combination of f bar s and f of t. Now you just imagine that this whole thing 1 by s into s plus 1 is your new f bar s, and this is the corresponding new f of t. Then can we not find out this expression? So it is like 1 by s into s plus 1 divided by s. Na? So this is 1 by s into s plus 1. So clear? So we need to do one more step. We need to just repeat the step. So L inverse of, you see, 1 by s into s plus 1 divided by s, this is equals to L inverse of 1 by s square times s plus 1, and you know the formula for this, 0 to t. We have to now put the new f of t, which you have got 1 minus e to the power minus t dt. So this is equals to integration of dt is t minus plus e to the power minus t 0 to t. So this is t plus e to the power minus t plus 1, sorry, minus 1. Option C. Tell me if you have understood or not. Yes, option C. Anyone has any doubt? Harry, did you understand this one? It's like this property we have applied 2 times. Look, if it asks you 1 by let's say s cube times s plus 1, what you gonna do then? Again, this will be your new f bar s, and this will be your new f of t. You can calculate it indefinitely. You can calculate from this. You can also calculate let's say 1 by s cube into s plus 1, you can calculate by doing this L inverse of 1 by s square into s plus 1 by s, 0 to t, this integration of t to the power minus t minus 1 dt, whatever value you will get, that will be the answer. From this, again, if you consider higher order, then this thing will become new fs, f bar s, this thing will become new f of t, and you can easily calculate 1 by s to the power 4 into s plus 1 and so on. So by repeated application of this formula, you can calculate for other terms. I hope this is understood. If anyone has any doubt, you can tell me. And look, this same problem can be done using some other method. So let me just show you that method also, alternative solution you can say. Alternative is very straightforward, which we generally do. Let us say f bar s is given to you 1 by s square times s plus 1, but this alternative solution is a little rigorous. This problem was given just to check your knowledge on this property, okay, but we can do it in this way also, the way we did it in class 12, a by s, we are just writing it as a by s plus b by s square plus c by s plus 1, okay. Then you can evaluate the value of a, b, c, and we can take the individual Laplace transforms. So this will be, if we take the LCM, s square s plus 1, so a times s into s plus 1 plus b times s plus 1 plus c times s square. This is an identity. The numerator is equal to 1. A times s into s plus 1 plus b times s plus 1 plus c s square, this is 1, this is an identity. So we can put, let us say, s equals to 0. So if you put s equals to 0, only this second term will remain. So b into 1 is equals to 1, so b is equals to 1. So one value we have got, b is equals to 1 by putting s equals to 0. Now if you put s equals to minus 1, these two terms will cancel, only c term will remain. So put s equals to minus 1, then c is equals to 1. Now let's say, let's put s is equals to plus 1, but now we know the values of b and c. A times s into s plus 1, 1 into 1 plus 1, so 2a, plus b is 1, s is 1, so 2, plus c is 1, s square is 1, 2a is equals to 3, 1 minus 3 minus 2, and that gives you a is equals to minus 1. So you got the values of a, b, c, and hence we can write that therefore f bar s, a by, so minus 1 by s plus b by s square, so 1 by s square, plus c by, so 1 by s into s plus c by s plus 1 we took, yes, c by s plus 1. Now it has come to our very known form. So we can write L inverse of f bar s is equals to minus L inverse of 1 by s plus L inverse of 1 by s square plus L inverse of 1 by s plus 1. So 1 by s, what is the Laplace transform of 1? It is 1 by s, so L inverse of 1 by s will be 1, so minus 1. 1 by s square, you see n factorial by s to the power n plus 1. So, if you put n equals to 1, you get 1 by c square. So, that is why this is 2 t plus 1 by s plus 1. So, it is e to the power minus t, clear, and again you get the result c. So, both the solutions are there. This second solution is little rigorous but easy, and using the first solution you can use make use of the property of the Laplace transform, and you can get the result very easily. So, you have to practice a lot to learn this. Once you learn this, you will be able to solve any question. This is an easy topic, not so difficult, provided you practice enough. Is it done? Let us move on to a very special thing, Laplace transform of a periodic function. When you know that you are taking a Laplace transform of a periodic function, then it has some special feature. Laplace transform of periodic functions. Let us say you have a periodic function f of x. F of x is a periodic function having period t such that f of x plus t is equals to f of x, f of x plus 2t is equals to f of x, 3t f of x. So, we can generalize it by x plus nt, where n is equals to 1, 2, 3 and so on. This is how periodicity works. Then for such a periodic function, Laplace transform of that function is written as 1 by, notice this formula very carefully, 1 by 1 minus e to the power minus s capital T. This capital T is the period of the function, integration 0 to capital T. This is not 0 to infinity, 0 to capital T e to the power minus sx fx dx. So, there is a modification in the formula of Laplace transform. You see 1 by 1 minus e to the power minus st 0 to t e to the power minus sx fx dx. So, whatever function you will be given, you have to identify its period. You have to evaluate its period. If you are given a graph instead of a function, you have to check what is the period, and once you know the value of t, the period, you can just put it into the formula and you are good to go. It's a very simple thing, but you have to remember this formula. Without remembering this formula, you cannot solve. Let's go for a problem. Look at this problem. This came in December 2011. The graph of the function f of x equals to 1 for 2n less equals to x less equals to 2n plus 1 and 0 between this. N equals to 0, 1, 2, 3, its Laplace transform of x. Look, this n and all things, this can make you confused, but if you see, if you put n is equals to 0, then this condition becomes 0 plus my less equals to x less equals to 1, and this condition becomes 1 less equals to x less equals to 2. So, one cycle you have got. Between 0 to 1 the value is 1, between 1 to 2 the value is 0. So, actually this is the cycle which is getting repeated, right. So, what is the period? This is one cycle, this is one cycle, this is one cycle. So, what obviously the period is 2. Do you agree? T is equals to 2 here. Which option you are getting? Ajay, Harani, just put it into the formula, nothing else. The given function is a periodic function of period t is equals to 2, and hence Laplace transform of f of x equals to 1 by 1 minus e to the power minus st 0 to t e to the power minus sx fx dx. 1 by 1 minus e to the power minus 2s 0 to 2 e to the power minus sx fx dx, or between 1 to 2 it is 0, so we can just take from 0 to 1 and you can put value of fx to be 1. So, this is 1 upon 1 minus e to the power minus 2s e to the power minus sx by minus s 0 to 1. Option C, yes, option C will come. this is equals to 1 by 1 minus e to the power minus 2s 1 minus e to the power minus s by s. Now you see, we can just write it as 1 minus 1 square minus e to the power minus s whole square. So 1 plus e to the power minus s and 1 minus e to the power minus s. Can you write it using a square plus b square formula? 1 minus e to the power minus s and s. So 1 minus e to the power minus s is getting cancelled from both sides. So 1 upon s times 1 plus e to the power minus s, matching with option C. 2 instead of 1, what? Zero to t was there, so 0 to 2 was there, but the function f of x has non-zero value between 0 to 1. So the limit goes 0 to 1 f of x dx, and 1 to 2. Okay, you can also write a line here if it is confusing. Okay. Second term is 0. Here e to the power minus sx by minus s, limit between 0 to 1. Then e to the power 1 minus e to the power minus 2s. It is like 1 square minus e to the power minus s whole square. Okay, got it now? Let's do this problem now. Let f of s be the Laplace transform of the periodic function f of t given in this form. F of t plus 2a equals to f of t. So it is already given. This is the time period. This is the period t equals to 2a. What is the value of f of s? Do it quickly. Graph is not required, but still you can check it. Zero to a to 2a. 0 to a it is 1. And between a to 2a it is minus 1. This thing you understand. This is piecewise continuous. In the property of Laplace transform, we told the condition for existence of Laplace transform that the function should be piecewise continuous. Piecewise means here it is one piece 0 to a, another piece a to a. So this is continuous between 0 to a. It is continuous between a to 2a. So there is a little bit discontinuity here. At t equals to a, there is a discontinuity, you can see. So this is piecewise continuous. Do it. The calculation will be little bit large, not large. Just applying the integration by parts. just go with the flow. Let's start up solving this question. देखो Laplace transform of f of t. This is a periodic function with period t equals to 2a, no confusion in that. 1 by 1 minus e to the power minus st, so minus 2as because t equals to 2a. Then 0 to 2a e to the power minus st ft dt. So 0 to 2a is written as in a decomposed form between 0 to a once, the value is 1, so e to the power minus st ft dt, and a to 2a, here the function has the value minus 1. Deep, you are getting option C? Yes, option C will come. Let's check it quickly then. This is equals to 1 upon 1 minus e to the power minus 2as. What will be the first term? E to the minus, so e to the power minus st by minus s between 0 to a, and minus e to the power minus st by minus s 0 to 2a. One upon 1 minus e to the power minus 2as. If you put, how many terms you will get? Just put the values. E to the power minus as by minus s, minus minus plus 1 by s, minus minus plus e to the power minus 2s by s minus 1 by s. One upon 1 minus e to the power minus 2s, if you take s common, 1, have you done any mistake? Ajay, you are also getting option C. अच्छा, यहाँ पे 0 नहीं है ना, a है ना, that is what I am thinking, a to 2a. Denominator will change, e to the power minus as by s. Okay, 1 minus 2 e to the power minus as plus e to the power minus 2as. ठीक है, this equals to 1 upon s, this 1 upon s we are taking, and this is, you can say that e to the power, okay, 1 a square minus 2ab plus b square. Can you write it in this way? Divided by, here we can write 1 square minus e to the power minus s whole square. ठीक है, I am showing you all the steps for the time being. The numerator becomes 1 minus e to the power minus s whole square, denominator 1 plus e to the power minus s, 1 minus e to the power minus s. So 1 minus e to the power minus s getting cancelled. So what you are left with? You are left with 1 by s, 1 minus e to the power minus s by 1 plus e to the power minus s. So the examiner could give options like this, but he wants you in terms of hyperbolic, tan hyperbolic. So we have to express it in terms of tan hyperbolic. What you can do to express it in the form of tan hyperbolic? So you can take e to the power as by 2 common. So e to the power as by 2 if you take common, so e to the power minus as by 2, that is 1, minus e to the power minus as by 2 divided by, here also if you take e to the power as by 2 common, e to the power minus as by 2 plus e to the power minus as by 2. So this is 1 upon s, and this is getting cancelled, and you get tan hyperbolic as by 2, matching with option C. Tell me guys if you have understood this or not. Everybody, you should like the video guys. Liking the video gives me good motivation. Once it is done, we will go for the Laplace transform of derivatives of a function. बताइए गाइस ये हुआ कि नहीं, कंप्लीट हुआ कि नहीं? Those who have completed can give this heading Laplace transform of derivatives of a function. Now this is very special thing, Laplace transform of the derivative. Simple formula is there. If you calculate the Laplace transform of the nth derivative f n of x, it means, what is the meaning of this? This means Laplace transform of dn by dx n of fx, है ना? So f n of x means this. This will be s to the power n, whatever power will be given. So s to the power n Laplace transform of fx minus, only the first term will be plus, then all the remaining terms will be minus, minus s to the power n was there, 1 unit reduced, n minus 1, f bar s was there. Now it will become the original function f of x at 0. Next term will be s to the power n minus 1 was there, so it will become n minus 2. Okay, power of f was here 1. This was the original function. So now here it will be derivative of this. So f prime at x equals to 0. If you write the second term, what you gonna write? Up to this it will be used, but do predict what will be the next term? Minus s to the power n minus 2, so it will be n minus 3. F prime was there, so it will be f double prime, and it will go on. What will be the last term? If you keep on doing this, s to the power n minus n will come, so s to the power 0 will be there, that will make 1, है ना? F to the power, it will be n minus 1, this will be the last term. Do you understand this? Because it has started from here, 1, look, this is like 0, 1, 2, 3 up to n minus 1, because this first term is not taken. So 0, 1, 2, 3, 4 and up to n, so n minus 1 term will come. This is the general formula. Now let us say if I use, okay, here one thing you remember, although I need not to say this, but you already know this, f of x is equals to f bar s, then these formulas are applicable. Now let us say we are calculating f prime x, Laplace transform of the first derivative. As per this formula, what will be there? S to the power n equals to 1, so s times f bar s minus s to the power 1 minus 1, so 0, so f of x equals to 0. Let us say if you are calculating f double prime x, up to this you will see in your examination. So n is equals to 2, so s square f bar s minus s to the power 2 minus 1 is s, f at x equals to 0, minus s to the power 2 minus 2, so 1, so f prime at x equals to 0. Understand this fine difference. In the first term we get Laplace transform f bar s, but in the second term you get the original function f at x equals to 0, f prime at x equals to 0 and so on. Although the up to this second order you may get in the examination, but let us go for the third. If you apply the formula, how can we write? F triple prime x means n equals to 3, so s3 s cube f bar s minus s square f at x equals to 0 or f of 0, है ना, minus s to the power 1 f prime at x equals to 0 minus f double prime at x equals to 0. All other terms will vanish. Is it clear or not? Tell me. Actually here we have written the last term, f to the power n minus 1. So 3 minus 1. So f2 x equals to 0. If anyone has any doubt regarding this Laplace transform of derivative, it's clear. चलो फिर एक प्रॉब्लम करते हैं. Let's do a problem. This simple problem came in 2017. Can you do this? Consider the differential equation dy dt plus ay is equals to e to the power minus bt with initial condition y at t equals to 0, then the Laplace transform y of s of the solution y of t is. So take Laplace transform on both sides. What do you get? Look, Laplace transform of dy dt. A is a constant. Laplace transform of y. Laplace transform of e to the power minus bt. Right? So Laplace transform of dy dt means Laplace transform of y prime. So value of n is 1. So s to the power 1. F bar s is given to you y of s, because in the question it is given Laplace transform of y of t is y of s. So this is your F bar s, na? So s time y of s plus a times Laplace transform of y is y of s. Achha, there will be another term, na, here. Minus y at t equals to 0 plus a times y of s Laplace transform e to the minus bt 1 by s plus b. है ना? You need to find out y of s. So let's take y of s common. You get s plus a. Y of 0 is 0, so it is not contributing, and as a result y of s is equals to 1 upon s plus a times s plus b. Option A. So simple. Now I am giving you a problem to do at home. You now understood how to apply this. Whenever you will be given a differential equation, you will take Laplace transform on both sides, and then you are good to go. Now there is a high chance that you may get an inter-subject question here, inter-topic questions. One topic from this Laplace transform and another topic maybe differential equation, non-homogeneous second order differential equation they can give you, and they will give such a differential equation that if you solve it with Laplace transform, then that will become very easy. One problem I am giving you to do at home, you will try. That will incorporate the concept of non-homogeneous second order differential equation, where you find particular integral and all. So this is that problem. Look at this problem. Consider the linear differential equation d square I by dt square minus 4i equals to f of t. F of t is the inverse Laplace transform of 1 by s plus 2 plus 1 by s minus 2. So first of all, you need to calculate this inverse Laplace transform. Then you can write the right hand side terms. then the general solution of the differential equation, then the standard procedure will follow, है ना. So this problem is a combination of the concept of Laplace transform and differential equation of second order non-homogeneous. So you will try this at home. Tomorrow at 7:30 also we will take the class and we can discuss the solution. And if you solve it before that, you can send the solution in on the WhatsApp group. And guys, those who have not joined our Telegram channel, you can join this Telegram channel. The link is given in the description. physicshub 111. Okay. So we are stopping here today. Thank you very much, guys, for joining the session. I hope you find the session useful, and see you guys tomorrow. Till then, bye bye. Take care. Have a great day.